Rahim. So dear students, we'll be talking today about the phase equilibrium. Now जो phase equilibrium है उसमें already हमने start किया हुआ है. The topic number 1 which we have completed in our class. So that was our phase. So the first important component of this phase equilibrium, that is how to define that phase. So that phase we have completed. इसको हम थोड़ा सा रिकॉल कर लेते हैं that the phase is defined as basically it's a physically distinct part of the system which is mechanically separable from the other parts of the system, and then it has the visible boundaries. Fine, ये तो हमने define किया हुआ. उसके बाद जो second term हमने की है that is the component C. The component we have already defined. The components actually the minimum number of chemical species which are necessary to be specified to define the composition of all the phases. ठीक है? So that we have also done. Now हमारे पास जो third topic है जो बहुत important है, that is the degrees of freedom, and then we have phase rule and derivation. So today we'll be talking about in this class degrees of freedom, phase rule and derivation of phase rule. So what I have done is that कि मैंने यहाँ पे ये try किया है कि we'll make them concise as much as possible, to the point concept, so that हमारा time भी नहीं जाएगा उसमें, and then we can also try to cover up our syllabus. ठीक है, we'll start with the topic number 1, degrees of freedom. This is our topic number 1. So the degrees of freedom means the minimum number of intensive or independent variables. Variables like temperature, pressure and concentration, or you can say composition. So there are 3 variables. The temperature, pressure and composition. Now ये जो temperature, pressure and composition है, among these the minimum number means either temperature or either temperature and pressure or either temperature, pressure and composition. So any two, any one. So minimum number as much as possible. तो minimum number of the variables जिनको हम fix कर लेंगे, जिनको हम एक specific value दे दें, so which must be arbitrarily fixed. Now the minimum number of these independent variables which we will fix, ठीक? So what the result of that will be, so that we should be in a position to describe the state of system. किसी भी system का state describe करने के लिए how many minimum number of independent variables we require, so that's called as the degrees of freedom. So independent variables, temperature, pressure, composition, ठीक है, in general. Now ये जो degrees of freedom है, it is denoted by the capital F. ठीक है? अब let's understand this. To understand this degrees of freedom, now we have here example 1, example 2 and example 3. Okay? So what do we mean by that? We need to arbitrarily fix the minimum number of variables so as to define the state of system. Okay? What do we mean by that? To understand that, we have these 3 examples. So basically ये variables निकालने के लिए हमारे पास एक rule है. Before we will go to these examples number 1, 2 and 3. It's better I will go first to that rule in the next slide, that is your phase rule. Okay? So what phase rule is actually, it was proposed by the Josh Willard Gibbs, J.W. Gibbs. This rule was proposed by Josh Willard Gibbs. So इससे क्या होता है कि it's basically it gives us a relationship between number of phases. किसी भी heterogeneous equilibrium में, thermodynamical equilibrium में, number of phases, then it correlates the number of phases with the number of components and the number of degrees of freedom. जैसे कि यहाँ लिखा हुआ mathematically F is equivalent to C minus P plus 2. So if you have any heterogeneous equilibrium, then you want to know the degrees of freedom, so that you can know with the help of number of components and with the help of the number of phases plus 2 using this formula. Remember, this is only applicable to those thermodynamical systems where you have the equilibrium. If you don't have equilibrium, you cannot use this Gibbs phase rule. ठीक है? So this rule helps you to predict the minimum number of independent variables like pressure, temperature, composition. So among these the minimum number so that we can define the state of any system. ठीक है? So now let's go back to those examples. So first example is we have a gaseous mixture that is hydrogen and oxygen. So, assume that we have a gaseous mixture here. Okay. This is a closed system. So in this we have gases like hydrogen and oxygen. Okay. Now we have two gas molecules, so that means the number of components is 2. So your C value is 2 here. So your C is 2. And then he writes that this system of H2O and oxygen, it can be defined by 3 variables. How can we calculate that? Simply use the phase rule. F is equivalent to C minus P plus 2 P plus 2. अब देखिए यहाँ पे हमारे पास we have 2 components, so C is equivalent to 2. Number of phases, homogeneous mixture of gases, it constitutes 1 phase. इसको हमने already discuss किया हुआ in the previous classes. So that is your 1 phase plus 2. So that is basically your, this is 2 and 2, that's 4, 4 minus your phase is 1, that is 3. So this is basically the F value for this is 3. That means it has 3 degrees of freedom. इसके लिए हम लिखते हैं it is trivariant system. So now from the with the help of the phase rule, हमने क्या किया है? We are in a position to predict the minimum number of variables which must be arbitrarily fixed to define the state of a particular system. So यहाँ पे we need 3 variables, so that can be pressure, temperature. In the composition we can use concentration, or we can also take the variable like volume. ठीक है? Or we can, so we need 3 variables here, so it's a trivariant system. Now let's go to the next example. Let's first go to this example, third example, then we'll go to the second one. Okay. Now this is water and vapor in the equilibrium. So that means it's a closed system. Let's say we have a beaker, it has water here. Now he says that there is equilibrium with the vapors also. That means some of the water is getting converted to the vapors, and it's a closed system. And then we have this vapor and water equilibrium existing. Okay, because only closed system can give us this equilibrium. Now ये जो equilibrium है, we need to predict the number of variables. That's the number of degrees of freedom. So if we use this equation, F is equal to C minus P plus 2, that is the phase rule. So number of components कितने होंगे यहाँ पे? Water is on both the sides, so number of components is 1. Now it's a 2-phase system, water and vapor phase. So your P is equivalent to 2, and your 2 is here. So कितना हो गया? That is 3 minus 2, that is 1. So degrees of freedom is 1 यहाँ पे. It's a monovariant system. So what does it mean? It means हमें एक ही variable को fix करना पड़ेगा. We need to arbitrarily fix one variable, that may be pressure, that may be temperature. उससे क्या होगा? The other variable will get automatically fixed. We know that ये equilibrium हमको achieve हो सकता है at a particular temperature and at a particular pressure. ठीक है? If you vary the temperature, the pressure will also get automatically fixed. So we need not to worry about the pressure. In though, then now to achieve this water vapor equilibrium, हमें क्या करना है? We need to fix only the temperature, and this will automatically get fixed. So it's a monovariant system. ठीक है? The degrees of freedom is 1. Now let's move to this example number 2. That is ice, water and vapor equilibrium. And as per him, he says that F is equal to 0. So that means it has no degree of freedom. It is invariant system. Now what does that mean? Now इस example को हम understand करेंगे in the next class, that is the phase diagram of water. But still I will try to go to the basics. So let's try to understand how F is 0 in this case. Let's move to the next slide. So we have ice. This is our ice. Water as solid. Then we have as a liquid form of water. I will write down it water here. Okay. So then this is an equilibrium with, that's the gas, vapor form of water. Okay. Now to achieve this, this is something interesting कि अगर आपके पास water है, then at the simultaneously you need to have ice, water and vapors in the equilibrium. This is only possible जब हम water phase diagram पढ़ेंगे, there we will understand this. This is only possible at a temperature which is 273 Kelvin and the pressure it's 4.5. It's approximately, if I can look at the pressure, it's around 4.5 mm of Hg. This is 4.5 mm of mercury. Now इन्हीं दो conditions में you can achieve that this equilibrium. ठीक है. So now as per, if we apply the phase rule here, F is equal to C minus P plus 2, the component is 1 here. Now phases कितने हैं यहाँ पे 3. Now 2, so that becomes 2 and then 2 plus 1 3, 3 minus 3, that is your 0. So that means the degrees of freedom in this case is 0. So इसको हम कह सकते हैं it's a invariant system, it's a non-variant system. इसका क्या मतलब? Means you don't need to fix any variable in this case. क्यों? क्योंकि ये जो equilibrium है, no matter whatsoever, wherever you are, whatever the conditions you apply, you can achieve this equilibrium only when the temperature is 273 and the pressure is 4.5 mm of mercury. So above the conditions or below the conditions, these two, you can never achieve any this system where you have water as ice, water as liquid and water as vapor exist in the equilibrium. So that's not possible. The moment you change the pressure or you alter the temperature, you will only get 2 phases. You will never get a 3 phases. So it's a non-variant system, it's an invariant system. Okay? So this is all about our degrees of freedom and phase rule. अब हमारे पास एक important question होता है जो exams में आता रहता है, that is the thermodynamical derivation of phase rule. Now let's go to the next slide, that is the derivation of phase rule. तो basically मैंने यहाँ पे इसको बहुत concise manner में लिखा हुआ है. Otherwise the definition is a bit tedious. It's the derivation rather is a bit tedious. ठीक है? So what I have tried to do here, look at this diagram. There's a diagram. This is a thermodynamical system. This one. So this ये जो system है, he says that let's consider a heterogeneous system. Heterogeneous already हमने discuss किया है, many phases. It has p number of phases. So basically the total number of phases is Pn. This is one phase. This you can see this one phase. This is another phase, another phase. So इस तरीके से there are n number of phases. So that's why I have written here Pn. So there are n number of phases. फिर यहाँ पे मैंने क्या लिखा है? Pn is equal to P. Why I have done this? So as to make the our derivation simple. ठीक है? So but actually it means the n number of phases. Now इस तरीके से जो chemical components है हमारे पास, we have n number of chemical components, C1, C2 and Cn. ये देखिए इस phase में भी we have n number of components, chemical species. इसमें भी क्यों? Because there is an equilibrium existing. हमने पहले भी कहा कि phase rule is valid only when you have the equilibrium existing. If you don't have equilibrium, then the phase rule is not valid. So you have to derive it. You have to assume that we have a system where all the chemical species are homogeneously distributed, and then we have the equilibrium existing. So you can see that this chemical species is distributed throughout all the phases, and we have equilibrium existing. Likely C2, C3, Cn. Cn means n number of chemical species. ठीक है? तो इस तरह से हमारे पास लाखों ऐसे equilibrium होंगे depending on the chemical components present. अब मैंने यहाँ पे फिर लिखा हुआ Cn is equal to C, so as to make our derivation easy. ठीक है? So यहाँ तक तो हमने assume किया है basics. Now if you recall the degrees of freedom, हमने क्या कहा था? Degrees of freedom is the minimum number of chemical components among the temperature, pressure and composition. Mainly उनमें से हमें minimum number चाहिए so that we can define the state of system. Now minimum number हम कैसे achieve करेंगे? जो total number of variables है, उन total number of variables में हमें कुछ minus करना पड़ेगा. That subtraction factor is the number of relations between the variables. वेरिएबल्स के बीच में अगर कोई रिलेशन एग्जिस्ट होती है, कोई इक्विलिब्रियम रिलेशन, So that will get subtracted to the total number of variables, and that will give us the minimum number of variables possible to define the state of system. ठीक है, तो इस तरह से हम निकालेंगे that degrees of freedom is equal to total number of variables minus the number of relationships between the variables at the equilibrium. ठीक है, अब हमारे पास क्वेश्चन यहाँ पे लिखा हो the total number of variables is equal to this much. Now ये कैसे इन्हें लिखा हुआ, that is the important point. And the number of equilibrium relationships, that is C into P minus 1, how is it possible? ठीक है, तो अगर हमें ये दो चीज़ें पता चल जाएं, ठीक है, then what we'll do, we'll subtract to this minus this, then we can get easily the phase rule. So we need to understand the number of relationships at equilibrium is equal to C into P minus 1. ठीक है, ये important point है. Okay, let's try to do this. देखिए, so let's talk about first the relationships. देखिए, अगर आप एक कंपोनेंट को फिक्स करेंगे, देन दो फेजेस के बीच में ये कंपोनेंट कितने इक्विलिब्रियम में रहता है? 1. 3 के बीच में 2, 4 फेज के बीच में 3. सो दैट मीन्स देयर इज ऑलवेज द फैक्टर कॉल्ड एज p minus 1. जितने फेजेस उनमें एक माइनस करो, सो दैट विल बी द नंबर ऑफ इक्विलिब्रियम्स विच द केमिकल कंपोनेंट बी इन्वॉल्व. ठीक है, अगर यहाँ पे Pn है, सो द नंबर ऑफ इक्विलिब्रियम्स कितने होंगे? That is p minus 1. So look at this p minus 1. होगा ये क्लियर? नेक्स्ट, ये तो हो गया एक कंपोनेंट के लिए. तो जितने आप केमिकल कंपोनेंट्स होंगे उसको मल्टीप्लाई करेंगे. C is the total number of components. So that's your C into p minus 1. So this is the total number of relationships at equilibrium between the chemical, between this composition variable. ठीक है, ये तो हो गया the number of relationships. अब हमें क्या चाहिए? We need the total number of variables. यानी टेम्परेचर, प्रेशर एंड कंपोजिशन, इसमें द नंबर ऑफ वेरिएबल्स टोटल कितने होंगे? ठीक है, अब देखिए हाउ वी डू दैट. पहले हम टेम्परेचर और प्रेशर की बात कर लेते हैं. विल एज्यूम दैट दिस थर्मोडायनामिकल सिस्टम, इसका जो टेम्परेचर है, जो इसकी टेम्परेचर एंड प्रेशर वाला जो ये दो पैरामीटर्स है, दो वेरिएबल्स, विल फिक्स देम. व्हेन वी फिक्स देम, सो ऑटोमेटिकली इट बिकम्स 1 plus 1. So that is 2. It becomes 2 variables. So this factor we are fixing. So we have 2 variables here, that is C minus 1 plus 2. तो ये हो गया आपका plus 2. Now we need this P into C minus 1. अब देखिए, अब हमें composition के कितने variable होंगे, that we have to understand because we have n number of chemical species. ठीक है, अब देखिए, किसी भी system में जो concentration है, that we also express in terms of mole fraction. ठीक है, so we write the mole fraction of, let us say हमारे पास एक thermodynamical system है, उसमें दो chemical components हैं. So we write down the mole fraction of A plus mole fraction of B, किसके बराबर होता है? It's equal to 1. That means अगर हमें A को डिफाइन करना है, हम कैसे निकालेंगे A को? That is 1 minus xb. Likely अगर हमें b को निकालना हो तो we write down xa minus the 1 minus xa. So कहने का ये मतलब है that if we have two chemical species, we need to understand only one chemical species. We need to trace out only one chemical species. अगर कहीं पे 3 होंगे, so then xa plus xb, chi a plus chi b plus chi c is equal to 1. And then हम किसी भी एक को आराम से निकाल सकते हैं, बट नोइंग द अदर 2. सो लाइकली अगर हमारे पास वी हैव n नंबर ऑफ केमिकल स्पीशीज, केमिकल कंपोनेंट्स, सो हम एक को कैसे निकाल सकते हैं? बाय C minus 1. सो दिस इज द फैक्टर C minus 1. ठीक है, सो नाउ सो दैट मीन्स अगर हम एक फेज को देख ले, देन as far as the number of variables in terms of chemical components is concerned, that is C minus 1. Now we have P phases, so that's P into C minus 1. So this is P into C minus 1 plus 2. This is the total number of variables. I hope you understood that. Then we can do easily, we'll subtract the total number of variables minus the number of equilibrium relationships. Then we solve this, we'll get F is equivalent C minus P plus 2. That is your Gibbs phase rule. ठीक है, so this is all about our today's class. So I hope you understood it. If you still have the question, you are free to write down on my personal number as a message. एंड इसके अलावा जो इम्पोर्टेंट चीज़ यहाँ पे है दैट इज़ दैट ये जो मैंने पढ़ाया यहाँ पे आपको, यू विल बी हैविंग ए PDF फाइल आल्सो अटैच्ड, यू कैन सी हियर। जो हमारी जो चैनल है उस पर आपका एक जो डिस्क्रिप्शन है, डिस्क्रिप्शन में आपको लिंक मिलेगा, दैट उसी लिंक में आपका ये जो पूरा मैंने पढ़ाया है इसका एक PDF फाइल होगा, एक PDF नोट होगा। यू कैन क्लिक दैट लिंक एंड यू कैन डाउनलोड दिस, यू आर फ्री टू डाउनलोड दिस एनी टाइम, तो आप इसको पढ़ सकती हो। सो दिस इज ऑल अबाउट आवर टुडेज क्लास। Hopefully the next class will come up with a very important topic, that is your phase diagram of water. ठीक है, so thank you for this.